Here is a very simple three-phase motor starter. It consists of only a start and stop button. When you press the start button, the motor will start and continue to run until you press the stop button, at which point the motor and anything else will stop running. Looking inside, it's made up of one large unit. At the bottom are three terminals, and the incoming voltage, the incoming three-phase power is connected to these terminals. On the top, there are three more terminals. The motor is connected to these, and a power feeder is also connected to these. The start and stop buttons on this panel, looking inside, are not electrically connected to anything. They are actually mechanically connected. So when you press the red stop button, this plunger pushes in. When you press the black stop button, the black plunger pushes in. On this unit, the start button touches the black plastic piece, and the red stop button touches this plastic piece. Now this black piece is a normally open switch, so right now there's no continuity across it, but when I press it in, now there's continuity. And the red stop button is a normally closed switch, so right now there's continuity, and when I press it in, now there's no more continuity. So the way this works is there is voltage applied across these in series, and that's connected to the coil which controls the contactor. So when I press the start button, there's continuity across both these switches, and that feeds the coil power, and that pulls this whole contactor assembly down, like that. And there's actually a plastic piece right here which physically holds the start button in place, so that even though you let go on the start button on the outside, it is still electrically connected inside and will continue to run the motor by basically feeding back power to itself. In order to stop this, you basically press this red stop button, and that will disconnect power to the coil, which causes it to immediately release, and when it's let go, there's no more power going through this, so it just stops. This is a very basic motor starter. Everything's combined in one unit. It has to be accessible right there at the machine. And yeah, it's about as basic as you can get. Here's a slightly more advanced motor starter than the previous one. It isn't more advanced in that it adds more features, but instead it divides up the duty of the motor starter into several modular components. One difference between this motor starter and the previous one is that the buttons to start and stop the motor are not located around the starter itself, but are located on the other side of the saw. On this unit, the buttons are connected by these wires right here. The incoming line voltage comes in at the bottom right here, and the outgoing power to the motor is connected to these wires right here. One main difference between this unit and the previous one is that there's now a transformer, and the only purpose of this transformer is to power the coil. Power line voltage goes in between the common terminal and whatever tap your incoming line voltage corresponds to. Power then goes out on the 24 volt secondary and is used to power the contactor. What happens is, when the start button is pressed, this 24 volts is electrically connected in the same manner as the previous starter to the coil. The coil then energizes in the same fashion, and the coil is electrically fed back to itself so that it continues to stay contacted. The power is fed through an overload relay and then to the motor itself. The purpose of the overload relay is if something would happen to the motor, say it stalled or the starting capacitor went bad and it failed to start, this would cause a huge surge in current, and the overload relay basically protects these components from damage. This is the motor starter out of a large 7.5 horsepower Shaper. Power comes in down here, goes up to this disconnect switch, which allows you to turn off power for servicing without having to unplug it from the wall. Power goes out here for a power feeder. Power goes to the motor through these wires. These 4 wires go to the start-stop panel, they go to the access panel, they go to other places throughout the unit. Down here is the transformer that will transform the line voltage to 110 volts for the coils of the contactors to operate off of. One of them is for running the motor clockwise, and one of them is for running the motor counterclockwise. I'm not sure which one goes to which. This right here is an overload relay. These contactors right here are special in that they have the 3 terminals to switch the line voltage. And they also have this terminal, and they've added an auxiliary contactor, which adds a normally open terminal and a normally closed terminal. So what happens is, when this contactor is engaged, it also engages this auxiliary contactor. The purpose of the auxiliary contactor is basically, one, to prevent the motor from trying to start in both directions at the same time, which will cause the A and C phase to short out. And the second purpose of these auxiliary contactors is to provide the feedback to the contactor coils, which keeps them started after you've released the start button. The way these auxiliary contactors prevent the opposite contactor from engaging once this one has engaged is this normally closed switch is put in series with the start-stop button for this contactor. So if this one is engaged, it basically disconnects this normally connected terminal, and if I try to press the start button corresponding with this contactor, it is stopped right here at this normally closed terminal. This normally open terminal is what feeds back power to the starting coil.